I'm Margaret Magdesian. I'm a neuroscientist, and I've spent the past 15 years of my life working in some of the best research centers in the world. I've developed a new technique where we can reconnect the spinal cord after injury. And my goal was to develop a new drug that could help 20% of the world population that suffer from neurological diseases, such as multiple sclerosis, Alzheimer's, spinal cord injury, Parkinson, and many others. But it was so frustrating because most of my time I spent in the lab doing research on cells and performing cell experiments over and over and over again. Why are cell experiments so important? Because every new drug first has to be tested on cells. Then they can be tested in animals, and after that they can be tested in humans. But cell testing hasn't changed much in the past years. And from 10,000 drugs being tested today, only one will arrive at the market after 10 to 15 years of research and over $1 billion investment. This is a very inefficient process. In fact, we invest in those highly qualified scientists, multi-million-dollar facilities to use expensive reagents and chemicals performing tests on cells on a Petri dish. Remember the Petri dish from high school science class? Well, we still use those. They haven't changed in the past 100 years. And there's no question that the Petri dish do not reproduce the human body. Cells on a Petri dish, those are nerve cells. They get entangled, they form clamps, and they do not look at all like a brain or like a spinal cord. So every time you test a new drugs, the results you get cannot be reproduced, or most of the time. In fact, 70% of the results from cells on a Petri dish cannot be reproduced. This is very sad. This is me in the lab, very frustrated, trying to do cell testing, get a new drug to help people with neurological diseases, and after a day of work, I could get one result or two. I talked to my friend engineer, and they said, why don't you change that? So we came up with a model, this one, where we can grow 120 mini spinal cords in less than 1 centimeter square. I could now get 120 results instead of 1 or 2. So our product is much better than how people are performing drug testing today. In fact, we're bringing drug testing to the 21st century, because if you see, we're in the age of data. How can someone get data from a Petri dish? Our devices enable cell organization so that you can scan the cells and easily compare what the effect of one drug and the other one. It reduces costs, is faster, and increases reproducibility. We received great feedback from the media and also from scientific journals. And we've sold over 2,000 devices to clients working on Alzheimer's disease and people that came to me and said, can you change a little bit the size? And then we tried to use it on cancer or parasitic disease, and it worked. Suddenly, a company approached us. I was at the university, and they said, we would like to order 10,000 devices. I was producing the devices by hand. Can you imagine how I answered that call? Well, I quit my position. I joined this team of visionary people, and we started a company, Ananda. We have people, great investors, such as Jeff Mallet and Yvan Baudouin from Desjardins Capital. We've raised over $800,000 to keep a $3 million revenue and deliver our first order finally. It has been great. It's a long ride, but we still need your help to reach 500,000 labs that can use my product. Please come and talk to us. We're Ananda Devices. Thank you.
Thank you for this presentation. Can you tell me more about the validation of your device? How did you validate it?
Well, I've been working on those devices for the past 8 years. I have developed, it's basically a mold where you can organize the cells. It's just like here, if we take a picture here and try to find out how people react to each presentation, if we take a picture of the people seated, it will be much easier because then we see how many seats are empty, how people are reacting, how they are calling. If you take a picture from there where everyone is more or less standing and then we put in a software to try to read it, it will be much harder to say, just to estimate how many people are standing there would be harder than people seating. So what I do is organize the cells in a mold, just like they are organized in the human body, making it much easier for imaging and comparison and validation.
So thank you very much for your presentation. How broad is your protection? Does it also include other types of, I would say, organs that you can use by using this method? And how does it differ from, for example, hyaluronic acid-based devices?
Yeah, our device has been used so far for any cells that move. So like parasites, sperm cells. We have other products in the drawers. In fact, I have more than 50 products in the drawers, and I just decided to open a company because I realized, if I stay in academia, publish one paper at a time, I would help science maybe in the future. But if I release those products, commercialize them, I will enable many other scientists to do research as well.
Would you consider building your company to become a pipeline company based on your platform?
Yes, of course.
Developing drugs?
That's my goal, is to sell all those products and help people in different fields to accelerate and basically bring automation to cell testing.
Two questions. The first one is, how does this differ from one of the many novel organoid technologies that are currently being developed?
How many of them are for the brain? Most of them are for the lung, for the lungs, for the heart. The brain is a very tricky cell type, and very few people can work with them. So our devices can grow brain cells for over 5 weeks. And we're also working with stem cell researchers because in our devices, cells survive much longer than current devices in the market.
And are these cells still the same cells after 5 weeks?
Yes, they are. We have published some papers on them.
Thank you.
Thank you very much.